Hey guys, this is the second lesson that we need to go through from Decision Mathematics. While last time we talked about the algorithms given in words and understand how the flowcharts can represent the algorithm and try to analyze them, then today we will talk about or we will focus on two next topics, and that is carrying out the bubble sort and quick sort algorithms. So those are the sorting algorithms that will help you to sort some kind of list that is unordered and put them to order based on the requirements. So the first one that we will talk about, you can find it on page 10 if you want to read through every single step, but I would prefer if I can show you directly rather than just reading, and I will show you on the example how it works and guide you through the steps. This bubble sort algorithm, or this algorithm, is used to sort, as I said before, to sort some list of items, whether it's numbers or if it's letters or words and so on, to some kind of order as required by the example or by the problem itself. This one, the bubble sort, does it by comparing adjacent values. That means those are the values that are next to each other. Okay, so let's look at it, how it works. So in this example, we are required to carry on the bubble sort, carry out the bubble sort algorithm to put this list of numbers 45, 56, 37, blah, 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 into the order that is ascending. Ascending order means that it goes from the smallest to the biggest. Let me see if my pen is going to work. From the smallest to the biggest, okay? If it's going to be the other way around, descending order, then it's going to be from the maximum to minimum. Okay, so the first thing, if you read the algorithm tells you you're going to compare the adjacent values. That means 45 and 56. Okay, so I'm going to write it down. And because these two are in order already, from the smallest to the biggest one, I just leave it. This is fine. And then I'm looking at 56 and 37. Okay, obviously you don't have to write it down. You can do the comparison in your head. But 56 and 37, they are not in order. That means I can switch them. And then I carry on, 56 and 79. These two are in order, so I just write 79 down. Now I'm looking at 79 and 46. These two are not in order, so I switch them. 79 and 18, not in order. That means switching. 79 and 90, they are okay. They are in ascending order, smaller and then bigger. That means I can keep it. 90 and 81, they are not in order, switch it. And then 90 and 51, they are not in order, so switch it. Now, once you reach the end of the list, 90 is at the end, this one is called one pass, okay? One pass, because you went through every single list or every single number in the list, okay? This one is called one pass. And after first pass, one number, the last number, is in its correct position. After the second pass, two last numbers are correct. After the third pass, three last numbers are in order, and so on. Okay? And now you're going to repeat the same steps until you are not going to make any swap, any switch between two numbers. If you will run through the line of the numbers without making any switch, that means you finished. The sort is completed and your list is in order. So let's look at the next one. 45, 37, switch. 45, 56, keep it. 56, 46, switch. 56 and 18, you have to switch. 56 and 79, that is in order. 79, 81 is in order. 81, 51, switch. And 81, 90. So this one is the second pass. And that means these two numbers are in its correct positions now, okay? And keep going. The third one, 37, 45, okay. 45, 46, 46, 18, switch. 46, 56, keep it. 79, keep it. These two must be switched. And then these two numbers can be kept, and this is the third pass is completed, okay? And now 3 numbers are in its correct position. And you can keep going. If you want, you can pause the video and try the next one on your own, and then I'll keep it without any, I'll do it without any comment. So 56, 79, 81, 90 are correct. Fourth pass is completed. And keep going, and I'm gonna finish the next. I think there are 2 more. Fifth pass, and then it's completed. Because if you go through it again, no need to switch, no need to switch, no need to switch, no need, no need, no need, no need, no need. You run through the whole list without a necessity to switch or to swap any of the neighbors. That means sort is complete and your list is in order now. So now let's look at the second example. In this case, exactly the same thing, except the order is descending. That means I'm going from the biggest one to the smallest one, okay? And after the first pass, again, the last number will be the smallest one at the end. Okay, so let's look at it. We're going to compare the first 2 items, 50 to 48, but they are in order because the bigger one is on the left side, so I keep it. 48 and 50 are not in order, so I swap them. 48 and 45, they are okay. 45 and 64, you need a swap. 45, 47, you need a swap. 45 and 53, you need a swap. First pass is completed, that means the last number, 45, is already in its fixed position. Next one, 52 and 50, they are okay. 50 and 48, they are okay. 48, 64 swap. 48, 47, they are okay. 47, 53 swap. And 47, 45 is okay. This is the second pass, it's completed. Now if you want, you can pause the video and do the rest, and I do the rest without any comment, okay? Now it's completed. So we had 1, 2, 3, 4, and 5 passes. Because in this one, you're not going to switch any number when you compare the adjacent neighbors or items. So the second algorithm that we need to talk about is quicksort. That is also sorting algorithm. That means it's going to put the list in orders, but it's using the method that is based on obtaining the pivots first. Now again, we can read through these steps, or I would prefer just to guide you through, okay? What is important is to notice this part, and I will remind you that when we will do it, okay? So example 1. We need to split the list first by obtaining the pivots, as it said in the definition, or how the quicksort works. So what does this mean? Means I'm going to write the list as it is given, and I'm going to identify the pivot. Pivot is the element, or is the item that is exactly in the middle. So in this case, it's number 56. So that's my pivot, okay? That split the list into halves. And in case you have even number of items, as you will see in the next example, you will always find the middle point, okay? And then you choose the item that is on the right side of this point, okay? That's the agreement, so we all do the same things. Now the second step said that we need to write the elements that are smaller than the pivot on the left side. Well, in this case, it's on the left side because I'm doing the ascending order. That means from the smallest to the biggest one. And the numbers or the items that are bigger than the pivots go on the right side. But please do not order them, because in here it's easy to see which number is the smaller or not, okay? But if you have 1,000 numbers, you don't do it. Our computer doesn't do it. So what do? You keep the order as it is. You just, if it's smaller than the pivot, it goes on the left side. If it's bigger, it goes on the right side, because I'm doing the ascending order, okay? So the next step would be what? 45 is smaller than 56, but 75 is not. So 75 goes all the way, it's the first element after the pivot, okay? So you keep 45, 32, 51, okay? 75 is not, 47 is not, 61 is not, 70 is not smaller, but 28 is. That's why 28 comes here, okay? And now, because you have 56 is the fixed position now, I'm going to do exactly the same thing as I have done in the previous step on both lists, on the left side and also on the right side. So this is how it works. I'm finding the middle item, that is 51, okay? And in the second half, the middle item is 61. And I'm doing this now 4 times. I'm doing it on the left side and I'm doing it on the right side, okay? So 45 is less than 51, 32 is less than 51, but also 47 and 58. And just then I'm writing 51. And on the left side of it, there are no numbers in this left side. There are no numbers that are more than 51, okay? So I just repeat 56 and I close 51. You can use the rectangle around. That means it's in its fixed position, okay? I don't worry about that. Similar story was on the right side. 61, 75 and 70 are both bigger than 61. That's why they go on this side. And there are no numbers that are smaller than 61. And I keep doing this and applying the same algorithm, the same step on the remaining list. That means in this case on this one, okay, and on also on this one. So in here, this is what I was saying. There is no middle element, but this is the midpoint. That means I'm choosing 47. And similar stories here. I'm choosing number 70 because it's on the right side, and that's our convention or our agreement. Okay, and now keep doing. So 45, 32, 28 are both or all less than 47. Then I fix 47 and there are no numbers that go on the right side. And I just repeat. You can rewrite it or you can use these lines if you want, or you can rewrite the number. And then 70 has no number. I mean, in this list, there is no number that is less than 70. Only, I'm sorry, the number that is bigger than 70, that's 75. And keep doing this until you have no item to choose as a pivot. Okay? So for example, here 28 is the only number that I can choose, so it will become my pivot, but I have no number to compare. And the same is with 45. There is no number to be compared, and that's why they are all pivots now. 28, 32, 45, 47, 51, 56, 61, 70, and 75. That means they are in order from the smallest one to the biggest one in ascending order. Now the good question is, why do you think it's called quick sort? Well, because it's done very quickly. The computer can run through and split these lists very quickly. The bubble sort, we didn't mention where that name comes from. It reminds you like when you pour the Coke or some a drink that has little bubbles inside, and it keeps bubbling through the list, okay? That's where the name comes from. Now, this is a good thing about the quick sort, that it can be used similarly. Of course, you can use the bubble sort on the alphabet as well, but you need to know the alphabet, okay? You need to know the order, because you need to know which letter is on the left or right side, which one is smaller or bigger, I mean their position, obviously, okay? So please make sure you do know the alphabet because it's not given in the formula booklet. And now the example says that we have the list of names and they represented Britain in some competition, and we have the names Roper, Palmer, Bowes, and so on, okay? So I just write their first name, first letter of their names, in case you would have two names with the first letter that would be the same, then you would keep also the second part of it, okay? There might be the problems like that. Maybe we will even do some. Okay, so I will call the alphabet now, so it's easier for you to see, and we're going to use the quicksort algorithm. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means the middle point is here. So what will be your pivot? Well, obviously the pivot here will be K. And now you're going to write on the left side of the K every single, because it must be in the alphabetical order, that means it must start with A, B, C, D, da, da, da. So on the left side must be all letters that are before K, that means these ones, okay? So R, P are not, but B is, okay? Y is not, T is not, but H is and G. And then the K comes, and any letter that comes after the K, that will go on the right side of the list. And then keep repeating, okay? I'm doing identify the pivot on this list and pivot on this list because K is already fixed. So what I have here, H will become my pivot, and I'm comparing these two lists, B and G. When you look at the H, B and G are on the left side. That means they have to go there. On the other side, I have 6 items, so middle point would be somewhere here, and then T is on the right side of the midpoint. And repeat the same, okay? B and G goes before H. After H, there is no letter in this list. And then T is your pivot, so every single element that comes before T come on the left side, and after T on the right side. And keep repeating, okay? In this case, which one will be your pivot? Of course, G. In this case, it's going to be P. And in this case, it's going to be W because it's on the right side of the midpoint. And if you have only single elements, they all become pivots now. And that means if every single item becomes pivot, that means your sort is completed and you can conclude it. So now it's time for your practice, but I will do it with you, or I will give you the solution right away. So we can try this example. There is a list of how many? 7 numbers, and you are required to write them in the ascending order. That means from the smallest one to the biggest one. Okay, that's always important to notice. So try to pause the video if you want. Try to do the bubble sort first, then the quick sort, and then you can compare the answers that I'm gonna give you in a few seconds. Okay. Good. So compare if you have 4 passes, that is important, and if after the 4th pass you got them in order, you got the items or the numbers in order. The same here on the quick sort, you have 1, 2, 3, 4, 5, 6 rounds, 6 pivots you had to choose, okay? I mean 6 times you had to do it. So you can check this example now. If you look at it, you have n items to be written in ascending order and using the bubble sort, okay? And you have the n items. And you need to find the expression for the maximum number of comparisons to be made. So imagine that you would have a list that is written from the maximum to minimum in order, in the descending order. And if you want to write it in the ascending order, that means the number of the swaps that you have to make is the largest one, yeah, in each pass. So if you have n items, that would give you n minus 1 swaps in the first pass. Then it would give you, I can write here actually, n minus 1 swaps in the first pass. Then n minus 2 swaps it would give you in the second pass. And keep going until you will do 3 swaps, 2 swaps, and 1 swap. Yeah, because if you have n items, the number of comparisons you have to do is n minus 1. If you have, let's say, 5 items, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, then I need to do 1, 2, 3, 4 comparisons. Okay, so when you look at this now, then you have, this is the arithmetic sequence, and in this arithmetic sequence you have n minus 1 terms. So as you know, the sum for the arithmetic sequence is n over 2 first plus last item or element in the list. So in this case it's n minus 1 over 2 times 1 plus n minus 1. So when you simplify it, then you would have n times n minus 1 over 2. So when we look at the B case together, you need to describe a situation where the bubble sort might be quicker than the quick sort. So now when you think about it, if you need to order the list of numbers or some elements that is to ascending order, that is already in order except the largest element, let's say it's 7 would be first one or somewhere else, it doesn't matter. If you do the bubble sort, you would only need to do one pass, because in every single swap 7 would move, and at the end of the first swap, at the end of the first pass, you would have 7 at the end, and the rest of the list is in order already. While for the quick sort, you would, if you have 7, 1, 2, 3, 4, 5, 6, then the first pivot is 3, so 1, 2, 4, 5, 6, 3, and then 7, and then you have to keep going. I have to find out the pivot on the left side, then this would be the pivot, and so on. So you can see while here the quick sort would continue, the bubble sort would be done after the second pass, because in the second pass you would not do any comparison. Okay, so this is one situation. Now when you look at the C case, we need to decide whether the bubble sort or quick sort would be quicker, and also you have to explain how you made your choice. So 1, 2, 3, 7, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 1. So when you look at the first one, the only item that is out of its position, if I'm doing it in the ascending order, is number 7. So that's exactly this situation that I just described. So in this case, the bubble sort would be quicker. Bubble sort is quicker. The reason why, because the only item that is out of its position is number 7. That's the largest one. So after first pass, the list will be in order. The list is in order. In the order. Now when you look at the second one, this doesn't have to be the case in this case, because if I would do the bubble sort and I need to go from the minimum to maximum, after the first pass, number 1 would only move here. After the second pass, it would move here. After the third pass, and so on. While if you're going to do the quick sort, then identify the pivot. So pivot would be number 5, okay? And all elements, 2, 3, 4, 1, 5 is the pivot that is fixed, and 6, 7. And now when you identify the next pivot, you would have number 4. So you do 2, 3, 1, 4, that's fixed, and 5 is fixed, and then 6 and 7 is fixed. And then 6 becomes pivot, 3 becomes pivot. So then I would have 2, 1, 3 is fixed, 4 is fixed, 5, 6, and 7 are fixed. And then the last one, 1 become pivot. So that means it will be first one and second one. So this will become fixed and then the next one. So I have 1, 2, 3, 4. 4 times I had to run the algorithm, while in the bubble sort I would have to do 6 passes at least. Okay, so in this case the quick sort would be faster. The reason that you can write is because in the bubble sort, number 1 would only move 1 place at a time with each pass, okay? So the next example is about the quick sort again, but in this case you have the names. Please, I'm not sure if in your book, because I took this example from the book, but there is a little typo here. This should obviously says 9 because you only have 9 names. Another thing what I want to point out is you have 2 names with the same first letter M. That means you're going to keep the second letter because the second letter is important for the order. Okay? In the A case, they are asking you to explain how to carry out the first pass of the quicksort algorithm. That means you need to describe it. You just need to write it, basically. So the first step, obviously, is to write down the list. And the first step afterwards is identify the pivot that splits, and you just write it also on the exam, that splits the given list to two sublists. And because I have 9 items in my list, that means I am choosing the middle position would be 5. The middle position is 5th. Position is 5th, and 5th name is 1, 2, 3, 4, 5 is Meller. Okay. And then I am placing on the left side of Meller, on the left side, all names that are before ME, and right side, all names that are after ME. Okay, that would be your first pass. And then the B case says first carry out first 2 passes of quicksort on this list. Okay, so this is actually what you're going to do, but you don't have to finish. What is good about it? So you just write H, S, F, G, M, E, C, M, I, W, and A. And then identify the pivot, what we said is ME, and I'm writing all letters that are, or the names in this case, that are below, that comes before ME, okay, so before M. Again, it's good idea to be quick with the alphabet, but if not, you have to say in your head A, B, C, D, and so on, okay? So ME is your first pivot, and then I'm going to write on the left side or before the ME, whatever comes. So H comes before M, so then it's okay. S comes definitely after. Then F comes before. Then G comes before. C comes before. ME is after. W and A. And then is my pivot that is already fixed. And the ones that I didn't have were these two, so ME and W. Now the second pass would come from this pivot and then this pivot. Okay, so first I'm doing this part that the letters that are before G, that comes before G, are F, definitely, then C and A, but H comes after G, right after. Then ME is already fixed. And then both S and W comes after MI. Okay, S and W. And because they ask for 2 passes, so if you want to complete the second pass, then I have to identify the pivots for the next one. So in this case, it would be C in this sublist, then H is the only item left on this side, and in here I have 2 candidates, but because the midpoint is somewhere here, the one on the right side is W. So in this way, second pass is completed, and I didn't notice before that we need to also write down the pivots used in each pass. So first pass, what we used were pivots G and MI, and in the second pass, the pivots that we would be using if we carry on would be C, and then H, and then W. Okay, and for this you would get 3 marks. So now it's your turn. Please look at set 1C on page 12 and set 1D on page 15. Each has 4 problems that I identify that we didn't even either do or you can try on your own. Obviously, all answers are back in the book, but the detailed solutions are online on the website I gave you last time as well. And anytime you run into some kind of problem that you do not understand or whatever, Monday and Tuesday before or after further mathematics, I'm here for you. And any other time when I am free and you are free, you have self-study and I'm free, I don't have any meeting or whatever, then we can also meet and discuss. Just keep yourself organized, keep your questions down, write it down so you can clarify it as soon as possible before moving on. Thank you guys. I'll see you next time.